introduction, ma'am.
Thank you, sir.
Yes. Well, short. Is my screen is visible to you, everyone?
Yes,
Hello.
sir, it's visible. It's visible, sir.
Okay, I'll switch off my video because I have very low network connectivity, so it may be difficult to share my presentation.
Yeah, sure, sure. No problem, sir.
Thank you for my inviting this wonderful 10 days national FTP by Divya Meena, ma'am. And I'm Dr. Manoj Prabhakaran, so I'm working as an assistant professor at Department of EC. And today I'm going to discuss or give a presentation about that. Uh, small. So I mean, not a short description. I mean, it's average discussion about that AI-enabled embedded system for autonomous robot. So here, this autonomous robots almost will designed by AI embedded system. We are going to discuss about only that embedded system parts, how this AI is interlinked with the robotics and how the robotics doing some actions and performance in the social environment. Okay, and the next step we are going to see that what are the content of this presentation. First, I would like to tell about that just an introduction about that AI and robotics. Then follow that tells about that application of the AI robotics, and I'm going to categorize that what are the types of or major categories of AI robotics. Then we follow that what are the tools are majorly used in recent days. That is a AI enabled embedded robotics, and from that we only going to discuss about that AMR. AMR is nothing but autonomous mobile robot, which is designed by embedded module. And then the importance of ROSs, that is introduction of ROS, how the ROS is really helpful for to actions of the robots and how it is performance can be discussed in the introduction of ROSs. And follow that by we see some AMR projects developed by embedded AI robotics in the community of NVIDIA's and some Intel projects. And final, I'll go if the time permits, we will see some demo based on the embedded AI models. So this is a presentation of my content. And next, we are going to see that what are the steps based on the content. The first, we all know about what is AI. So yes, nothing but just machines or computer system which is designed by the humans. It can be programmable without any interference of the human, and it has some actions and performance by that technique like machine learning and deep learning. And I'm not going to describe over the details, and because we all know about the what is AI, let us come to that main part is what is robot. So robot is nothing but it is just a active artificial agents. We can say why we can say the artificial agents because how the humans are activating the same aspect the robot can be performed. That's why we can say that an active artificial agents, which is really helpful for the environment by the physical worlds, which is described by Russell and Narving. And here this diagram tells about that how uh, nowadays this has been more related to the robotics and artificial lens come up into the artificial intelligence robot. So let's see how it is going to work on that in the previous slides. I mean, next slides. And now the Robot Institute of America can be described also that it can be programmables and multifunctional of manipulators. That is a degree of 6 degree of different degree of freedom of manipulators or mobile platform robot. Anything can be designed to move some materials, grab the objects, or it can be tools we can run through the variable program motions for the performance of various tasks. So this is described by the Robot Institute of America. And for the any type of robotics can be has made up of these basic three laws of described by Isaac Asimov. The first is may not injure the human beings or through the any actions of the robot, which is allow the human beings to the harm things. That is the first law. And second thing is it compulsory must obey the order given by the humans, which is being except where such as order would not conflict the first law. And the third law is must to protect its own existence as long as much possible, but it not does not conflict the first and second law. So if the three laws are the robot has to be follow that any type of the robots. Okay, these are basic three laws. And next, we're going to see the what are the applications of the robotics. So here I given the some picture about that. What are the current dates of robot can be involved based on the AI embedded system. The first is Starship technology, which is useful for that. I mean, marketing phases are there, and insect robot. So insect robot is nothing. It is really helpful for to spy the people's and which are really helpful for to monitoring the football court or tennis court and the Molly robot kitchens, which is do some cooking part. And next we are going to see the Foldermates at city cargoes and spot mini Boston Dynamic robot, which is really innovative and more feasible, accurate of the robot nowadays. And Faro is just communicating that to the older peoples. And we have so many applications. And next we're going to see that the robot is really helpful for that healthcare department. That is a hospitalized and setting the treatment of infected disease like a COVID persons or any highly affected persons. We cannot enter the human being. So that's why the robot can be really helpful this time. And next, we are going to see that telemedia and teleport and surgery. So nowadays, when we go with many minute surgery, the robot can be helpful for do this some operations and also monitoring that or communicating the patient through the online, and the robot can be interaction to that conversation of AI. And finally, the manufacturing. So manufacturing is nowadays any most of the car industry is using the cuckoo robot. The cuckoo robot is a very advanced robot and do some more multifunction to design the car as well as any type of hardware material like CPU generating. And next for the robot bankings and robot warfare, the robot delivery. So these types of robots are used in these nowadays for the application purpose in environment and supermarket, autonomous vehicles, and agriculture. So now, so after these applications, how we have some literature survey, and we find out that the most of that robot can be more usable in commercial purpose and consumer purpose. And before 2015, the market price will be the increase around 87 billions when we compare with the nowadays, and very less part in the military and industries. So our we can suggest that we can see that the very less number of robot can be used in the industrial and military, but from our commercial purpose, we are using more than that compared with the military and industries, and also the consumer like a supermarketings and what hospitalized. So everything can be used in these drones or manipulator robots, or it can be conventional AI. So this is over the applications and future of the robotics. Next, we are going to see that how the robot can be designed and what are the tools of designing of the robot by embedded modules. Next, we see that categories of autonomous robot. So we have, I just categorize into three part. First is autonomous mobile robot. So autonomous mobile robot is nothing but a just type of uh, learning from the learning from the own techniques or mapping functions. It designed that own path and it do some certain actions using that by the help of AI. That's why we call the autonomous mobile robot. The autonomous guided vehicle is nothing but the human can be given some predefined functionality, and that functional only the robot can be do some actions. That is autonomous guided vehicles. And the remote operated underweight vehicles is nothing but just underwater robots. So these are the categories of autonomous air robot. Now we are going to only see about autonomous mobile robot. Uh, Either it's manipulators or it's maybe moving vehicles, or it may be a universe UAV model, that is a drones model. So these are the comes under the autonomous mobile robot, and we are going to only see that how that embedded models can be related with our autonomous mobile robots. So next is the autonomous mobile robot. So here this picture is tells about that just outline of autonomous robot capability. So here we have this autonomous mobile robot.
Sir, Manoj sir, once again, sorry for the interruption.
Yes, sir.
I'm not sure like if it is with me or everyone else, but your screen is still in the first slide.
Oh,
Yeah, right now it's in 16 slide.
now Now it is visible, ma'am.
Yeah, it's in 16 slides, sir. Yeah.
Now it is 16 slide, right? So can I
Yeah,
come with
yes, sir.
first onwards?
No, I think it would be enough if you just could show us the slides alone, because we were able to listen to you, but the slides were invisible for us.
Okay, fine.
Yeah.
So this is just changing the slide.
Yeah,
So
okay,
this is
sir.
the first AI, and next is a robot. So make it as a read view. So read view, you can see my read view, ma'am. Is it visible?
Yes, sir.
Is it
Now
changed?
this is perfect. Yeah, it's changing.
Oh, okay, fine. So this is tells about the robot, and we have three laws. The first is human cannot be injured. That is the first law, and second law is obey the order of the human, except that conflict of the first law. And second is that it can be protect the own existence as long as possible, and also not conflict the first and second law. So this all tells about the robots, and we have so many applications like Starship technologies, insect robots, speech, Molly robot kitchens, and we have that Boston Dynamics Sparrows and Kita Cargo. And for the health department, we have some cleaning process and interacting with the robots of infectious disease persons and telebots and robotic surgeries and robot for the manufacturers. So these are the applications. So next we're going to see that what are autonomous robots and how the autonomous robots as a part of embedded modules and what are the embedded modules are going to work on the autonomous robot. So this is autonomous robot, just a outline structure of the autonomous mobile robot. So here, whenever we going to take a design of autonomous mobile robot, there is a one important point part is your embedded models. So based on your embedded model, can be it can be uh, that action is be more accurate and more efficiency. So here that you have to choose what type of application has to be taken for the autonomous mobile robot, and what are the sensing part and what type of algorithm can be implemented in autonomous mobiles are very important. Nowadays, the recent techniques is a VSLAM. We can say that visual stimulation, localizations, and mapping algorithm, which is do that localization of the robot and also as well as the mapping of your robot. Because the navigation purpose, we need some mapping that robot can understand what are the action he has to be performed. So these are the main important algorithm that is a visual SLAM. And the coming to the what type of sensor we can carry out for either computer vision technique like image processing as well as NLP. So from these signals, the robot can be performed either capturing the image to define the what type of object it is, and it is really helpful for to grab the objects. So these are autonomous mobile robot, and in this picture we can see this what are the main models, that is a control model, compute models, and sensor and safety model, that is a program logical circuits. So from this action, it can be connected with either it's a promising AGI techniques, or we can connect with that data can be transferred to that data analytical parts. So many applications can be interlinked with the autonomous mobile robot. So next we're going to see that articulated arm robot. So in this arm AI robot, here I given the picture of six-axis manipulator. That is a 6 degree of freedom of robot. It has several joints and links. So we have two type of joints. One is a revolve joints and prismatic joints. So revolve joint, which is nothing but it can be rotation action. Prismatic joints can be only moves towards that translations. And here the what are the components we can see that actuator, sensor, and vision system. So these are the inputs which is really helpful for the robot and do some action, especially for the best example is manufacturing. So manufacturing is we can the manipulator, that is a cuckoo robot, to capture the image and grab the object and place in the correct uh, I mean that environment of the car, and it fixing the all parts and come to that the good product by using help of the cuckoo robot. So this is one of the articular arm AI robot, and here this potential industrial roles are, it has multi-axis motion control. So let us say about that role speech, yeah, and these are the axes which is really helpful for do some certain actions, and the robot can be performed. And next is safety functions and robotic control. To me, the very important thing is robotic control. which is really calculated by the mathematical expression like DH parameters. And also we have some motion path plannings. So motion path planning is one type of action to grab the object. So these are the main software that is the potential internal role of your articulated arm A robot. So next we're going to see the what are the tools of for any type of robot AI. So whenever we're going to design any type of robots, so these are the tools. One is the software tools and the hardware tools. We all know about that. So in this robot, we can say that the brain of the robot is software. So whenever we have to design some certain robot, we have to go with some first is simulation part. So here this software part, there is a ROS. So ROS is called robotic operating system. So, so whenever we go into design robot, we have to implement it or given some certain actions in the ROSs. That ROSs do the certain actions like motion path planning, so capturing images, sensing the elements, data transmitter, everything come under that ROSs. Here we have certain tool. First, I would like to tell about the robot analyzer. So robot analyzer just a tool to design a manipulator robot. That is your articulated arm robot, and it can be do some performance and the certain actions through the tool. And it's a robotics tool for the MATLAB and robotics tool for the Python. So in MATLAB, we can also do that robotic designs, either it's a manipulator or wheel robot or any UAV models. And nowadays we are have the toolbox for the Python. So using the Python, the robot can be designed. So next is a gazebo. So gazebo is one of the tools which is really helpful for to construct the 3D model and 2D model of your robot in the environment. So so before designing of any hardware robot, uh, I prefer that using the gazebo is a very easiest thing and important tool for designing of any type of robot. We can see that how the robot is performed, either it's moving from one place to another place or grabbing objects or pick and place objects, whatever it is, we can see in this through the tool of gazebo. And also the RVS is one of the parallel tool for the gazebo. In this RVS, we can see that extra detailed information of your manipulators, what type of axis, what type of rotations, everything we can see in this tool. That is R visualizations. That is the R transformations. That R transformation, nothing but it gives the details about the rotation translation of your robot. And next is a move it. So move it, which is really helpful for whenever we interlink with our NLP or computer vision toolbox to perform certain action, for example, object trackings or object picking places. This movie is very helpful for do the to see the simulation of the robotics as well as the VREP. And next is Intel OpenVINO tools. So this is a very advanced tool. This is an Intel OpenVINO tools. So whenever we go with any high-end robotics, this tool can be really helpful for do some action of the robot, because the AI can be has some library like different techniques or TensorFlows or CAFE, MXNets. So what are the predefined libraries or tools which is interlinked with our Intel OpenVNI tools. And then next is the ISXM with Omnivorous, developed by the NVIDIA. This is also a very important tool, which is a high-end 3D construction of your robot, any type of robots. So nowadays, this NVIDIA ISIS simulator is using to design that, for example, the Boston Dynamics or Mars robot. So whatever the robot, this omnivorous ISXM simulator is really helpful for that. So here, this red colors are highlighted that these are the recent advance of the tool for the robotic in software module. Let us see about the heart of the robot is the hardware part. So whenever we're going to the real-time implementations, we have to choose the correct embedded part. So previously, we can use that any type of robot can be designed either microprocessor, microcontroller, or different type of ARM processors like STM3898 models or Arduino board or Raspberry Pi models. So these are the hardware part, that is embedded models, really helpful for design the robot, and it can only perform that small action of the robot. For example, the predefined tracking path of your robot. The best example for this hardware part, using this hardware part, that is Arduino board and Raspberry Pi. And only we can implement it computation part and machine learning part in this model, not in the deep learning techniques. To improvise that, they companies come from the Intel and Nvidia. They develop that two embedded boards, not two embedded. They have different embedded boards are there. The Intel we have x86 model. Nowadays they're using that Atom or a core to for designing the robot, do some big action like a Coco robot for manufacturing the car, and also Intel FPGA. So this is a Cyclone 10 model only. It is used. These embedded boards are using for the robotics. And for that, next is Intel VUPS. VUPS nothing but the vision processing unit. So we can say that for when we interlink with our computer vision process or image process, these VPA has been to connect with the either x86 model or FPGA model to for do the actions of AI part in the robotics, as well as we have to connect with the GPU. That means a GO4, GTX or RTX graphics card. So these are the three, main hardware part in the Intel, designed by the Intel. And next is another important embedded family is we can say the NVIDIA. So there can be categories in the three part. The first is the Jetson family, and we all know about the Jetson family. What are the tools? Right now they are exploring into that robotics. And next is the Clara and Drive. So Jetson family, we have around five models are there, which is really helpful for to design any type of robot. Either it's a design for the robotic in the supermarketings or path plannings or mobile robots, whatever we can design in the Clara, Jetson. And Clara, the Clara is mainly useful for health health purpose or monitoring or so robotic surgery. So the Clara is really helpful for that design the robotic in the robotic surgery. And Drive, so Drive is only useful that model in your autonomous car like a Tesla or Hyundai. So these are the companies are using the driver embedded models. So these are the main hardware part and software parts recent days are using for the robotic AI models. And next we're going to see that AMR Intel parts. So how it is, just to tell about the architectures and what are the components are used in that. First, I'd like to tell about that software architecture. So in that OpenVINO, that is your tool, software tools, and how what it is working. That so these OpenVNI used to for do some certain actions like medieval libraries, that ROSs. ROS is nothing but robotic object system. It can be do that actions of the robot, and either it's a transforming the information from one node to another node or passing the messages. Everything in we can see in that ROS 2.0. So let us see. I can. Is it my screen is visible?
Sir, yes, sir, yes, sir.
1 minute. Just thinking that my pen.
So you're in slide 4 now. Yes, slide 19.
Yes, yes. Make it as a current slide. Okay, let us take this. Yeah, need a pen. Now it is visible, ma'am.
Yes, sir.
So whenever you're using the Intel config or Intel model, we have to have a separate OS of Ubuntu. We have to choose only the Ubuntu OS because we have to update the library every time, and it is real for to configure the robot very accurate and very efficiently. And next is the middleware libraries and mapping and planning. So as I said already, the mapping and planning, we have Visual Slam. That is your simulation localization and mapping. And it's very helpful for to do the uh, robot can perform its own actions, whatever it may be. It can be either picking or grabbing the objects. And fast mapping. The fast mapping, nothing but these Intel processors is really helpful for construct the 3D, either the 2D, to see how the rooms are environment look like that. So this fast mapping really helpful for that. And multi-camera slams. So multi-camera slam is nothing but we can come up with that either LDR or a depth camera, whatever it may be. It can be collect the all data together and do the mapping function of the robot. And the precision, so precision is nothing but we have what type of localizations and what type of parameters and actions, and how the robot can be moved from either the end effector or forward kinematics or reverse kinematics comes under the perceptions. And the main middlewares libraries are RVSs. So here RVSs 2.0, which is say about that uh, nowadays we have the Neotic Nijamias and no, Melodia Morning. So these are the two updated version of RVSs. Here we can implement in this RVSs, and the RVSs to real sense. So here the RVS real sense is nothing but the Intel uh, given that tool, that is a depth cameras, which is can be really easily interface these type of board, that is a Intel embedded board like a Atoms or a Core, whatever it is. So this is the architecture of your, Intel AMR. And next in this image, you can see this what type of embedded can be used in this. So let us see that. So as I said, discuss previously slide. So we have five models are there: Intel Core, Intel Atom. So these are the Intel 80X model used in the autonomous mobile robot, and Intel Movies and Cyclones are Intel Movies is really helpful for the computer vision part, and with that AI enabled techniques. And Cyclone is a FPGA model, and Intel graphics. So either you can use Intel Core or Movies or Intel graphics or Atom Movies or Intel Cyclone Movies Intel. So these three combination can be really helpful for to design a robot using the Intel product. Okay, and next slide. Is it my screen is visible now? Let us-
Yes, sir.
Okay, fine. So next coming with the software tools. So here the Intel developed the OpenVINO. In this OpenVINO, we have libraries like TensorFlow, the PyTorch, CAFEs, or MexNet, Keras can modify and given as an OpenVINO toolbox. And this Vino toolbox, OpenVINO toolbox, we can interlink with that more debug our processes or dump the code in this embedded model like a core atom. So these are the CPU, that is the 86 model. And for the GPU, we have a Xenon processor, not a GPU, it's like a GPU with a Xenon x86 model. And Iris is one of the graphics card. Graphics processor and HD graphics processor. These are the two iGPU processor, which is really helpful for do the 3D construction of the robotics and Movidex. So Movidex is nothing but the computer vision part and image processing. This is a vision processing unit is really helpful for to construct the robotics. So these are the software tool and how that tool can be interlinked with these embedded models. And next we're going to see that NVIDIA part. The NVIDIA embedded models, we all know about the Jetson Nano and Jetson Xavier, Jetson TGX, AGX, Xavier models, and Dorian. So these are the recent days that the NVIDIA are developing a embedded boards for designing constructed robotics or autonomous vehicles, whatever it may be. And next is the Clara AGX. The Clara AGX mainly used in your health department, that is your robotic surgeries or uh, analysis of MRIs or CRS camera, whatever maybe. So really, Clara AGX really helpful for that. And driver AGX. So driver AGX is these tools, embedded models is really helpful for you analysis and diagnosis of your autonomous vehicle like Teslas or Hyundai auto EV vehicles, whatever it is. Sorry. So these are the three main embedded models developed by the NVIDIA. And here, these from the embedded model, they can be categorized into separate software tech architectures. One is a Jetpack. So Jetpack is really helpful for that only implemented in the Jetson family, not interlink with our Clara and driver AGX. So here the same step we can interlink with our deep learning techniques and ML techniques. From the ML and deep learning techniques, the robot has to do the certain actions like capturing images, finding the density of objects, species identification, whatever it may be, we can do in this software, that is a Jetpack tool. And here this RVSs, ISAC RVSs can be implemented with a Jetpack. Next is ISAC Sim. So ISAC Sim is another tool which is really helpful for to construct a robot, either it's a mobile robot or wheel robot or manipulator or it may be a UAV, whatever it may be. So we can using the simulator, the robot can be do this action. It be a very accurate and efficiency. So the next is the software architecture of the Isaac sim. So here the Isaac sim, as I said already, here same step have mapping and planning. I mean mapping and localization of the robotics. So here we have visual slam. The same techniques are used in these Isaac sim architectures, and also we have numerous gem techniques. We can say the gem is nothing but either it can be a segmentation process or 3D object positions or reinforcement technique can be implemented, or you can update your GPS setting of your modules, and deep streaming for the robotics or collision avoidance or 3D 2D construction of that manipulators, or it can be interact with your gesture recognitions, and the gesture recognition the robot can be activated or conversion AI, whatever it may be, it can be comes under the Isaac gem. So this is software package can be comes under the Isaac sim architectures. So finally, this model can be implemented either it's a NVIDIA AGX model or Orient model, or it can be AGX TX Xavier. And also you can implement these model in the NVIDIA DGX station, that is a workstation processor. Okay, so these are the Isaac sim architecture, and so same aspect of this Isaac sim rows. So here the rows can be both in the middleware and the main node. So here the data can be transferred from one node to another node, and also it has a multiple node access. Everything can be comes under the Isaac node. So these are advantages of Isaac sim, and this is a simulator. So I'm giving the picture of the Isaac sim simulator. Here you can see these different type of robotics, mobile robots, or uh, and also the I mean warehouse robot, and also manipulators, that is a pick and grab objects. Everything we can design easily in this Isaac simulator, but it is a very high end definition tool. If you are installing this Isaac simulator, we need high end specification configuration, like either it's a either it's a graphics card like GTX 3090 Ti, and with a 32 GB RAM. If you have that, we can install that Isaac simulator and we can design any type of robot. So these are the advanced techniques in embedded platform, that is your NVIDIA and Intel techniques, I mean Intel models. Next, coming to the ROSs. So whenever we're going to design the robot, this ROS is very important, because uh, we are implementing the AI-enabled system robot, right? So AI, which is do some certain actions without any human interference. So this ROS is really helpful for do the robot actions with interfacing like a different technique like deep learning, machine learnings, and image processing, whatever it may be. So here the ROS is just an open source, and it has some meta operating system for the robot, and it also has some service provider like a hardware abstractions or different functionality and package collections, and also community level computation graphics level. Everything can be comes under this ROSs, and also it has provide some tools and library for obtaining the robot or building writings, or and easily can be write the program in your ROSs technique ROSs software packages. So here this images tells about how the RSS will be activate, and how the robot can be worked at. So here in this first image you can see the RSS master. So here the RSS master, which is really interlinked between the number of multiple nodes. The multiple nodes, we can say the publisher node or subscriber node. So publisher node, it has take some one actions, and the publisher node give the token to the RSS master. That RSS master check that what are the nodes are very free, and these publish can be executed in the subscriber node. So the RSS master activate the subscriber node, and the topic can be the pre-communication between the publisher node and subscriber. Now the information, that is a message, can be passes from publisher node to subscriber node. So this is the outline structure of the robot. Okay, so this is how the robot can be performed. It cannot be directly interlinked with the message cannot be transmitted from one node to another node. It go to the first master, and the master check the any client node is activate. If the client node is activated, it give the information to the publisher node. Then the message can be passes through the one node to another node through the topics. And next you see that using the image processing, the camera, that is a, let us consider the publisher node is the camera node, and the image processing is a subscriber node. So the input taken from the camera node that passing through the RSS master, then the robot do that classifications or of the object. Let us say this is a task, and the RSS master do the image processing techniques and give the action to the camera node. Then the information passes from camera node to the image processing node. So this is the process of RSS node. And next, see the images of ROS descriptions. So here that the green color, which is indicate that the recent, I mean, advanced RSS module, that is a neotic is. So whenever we're going to design any type of road at this stage, either we can use a neotic is or melodic marina. Okay, and we have so many versions are there. So I prefer that use some neotic is or melodic marina. So if you go with the previous model, it's very difficult to uh, update your packages and interlink with the updated package in the older versions. So the robot cannot be do the certain actions. So I prefer that the first tools are very good for that. And next is RVSS characteristics. So whenever we take the RVSS, we have four characteristics. One is the plumbing plus tools plus capability plus ecosystem. So these four main parameters tells you about that the ROS characteristics. So plumbing nothing but what type of process management and how the communication can be interlinked with one device to another devices, and what type of drivers can be used in this RVSS. Everything can be described in the plumbing. And the tool. The tool is nothing but visualization of the robot and the action of the robot. Everything we can see that through the tool and capability. That is the planning, mapping, manipulations, and ecosystem. The ecosystem nothing but how these type of robot can be interlinked with our society and how it is working, and what type of documentation can be stored in that tutorial sections. Everything can be seen in that. So whenever we go with always characteristic, these main parameters has to be followed. And fundamental of ROSs. So we have four main fundamentals. The first is the file system, and second is a computation graph, and third is a community level, and fourth is a communication in ROSs. Let us see first is the file system. The file system is nothing but uh, the collection of data. So the collection of data which is stored in this either it's meta packages or packages. That packages as follow from one node to another node, either through the service or it may be a messages. So here we have a category that is a package manifest, messages, services, and code and miscellaneous. So this comes under these main parameters. The package can be moved from one, that is a publisher node, to subscriber node through the meta packages. So this is the file system. And next is the computation graph. So this is very important for every ROSs. So let us see that whenever take any type of ROSs, you have main part, that is a master. Okay. So in this master, it can be connected different number of nodes, either so no connected from node 1 to node n, and it has to do multi-functionality at the same time. So that is a very important advantages of ROSs. Either it can be data collected from the video, or it can be sensing the object, or segmentations, or it may be a action of the robot, whatever it may be. So data can be transferred through the master only, or it has the permission of the master. Let us see that node 1. So node 1, it can be sending the messages through the topics, and the topics sent to the master. So the master will check that what are the output nodes are there. Once output node is activated, it giving the information to the topics, and the services waiting that token node. If they receive the service token values, then the node 1 is directly transmitted to the node 2, that is your output client. So this is the computation graph of your RVSs, and here is the bags. So bags is nothing but if any delay or something to be interrupted, these bag information which is related for storing the values. Okay, and next is the community level. So community level is nothing but after any implementations, there is a developed some community group to making some interactions or answerings or in the vlog or repository or distributions or code sharing, whatever it may be. They can be placed in the some community level. That is our community level. We have a website called www.wiki.ross. So from this we can make a conversation or make a updated version of any type of module or ROSs, we can exchange through the community level. And next is the communication ROSs. So as I said already, same process. So here the talker node and listen node. The talker node sending that token bus, that is your service information. Once the ROS is master is checking the what are that client is activated. Once the client is activated, it's sending information to the talker node. The talker node directly information to the listener node. It's a talker. I mean, hello. So this is a basic introduction. I mean, basic communication in the ROSs. So same step whenever we are doing any uh, task. So this is the process of your ROSs in robotics. So next is the navigation stack. So we previously we see that how the information passing that. Now the navigation of the robot. So here the navigation robot, we have a two main uh, main important parameter of the input is automatic source and sensor transform. So automatic source is nothing but it going to tell about the what type, what is the position and how that mathematic models of the robotics and the angle and rows and pitch, whatever maybe it can be comes under the automatic source, and the information passes through the main ROSs. And same step, if you're having any sensor element like cameras or any type of sensor materials, the information sending to the TF messages, that is the transform messages. So these information sending to the main ROSs, and there is an algorithm called visual SLAM, that is a simultaneous localization and mapping algorithm. It do that both global path planning and local path planning and motion path planning. Everything comes under together and do some actions, and it has some behavior of that AI and using the sensor source and map server. So this is the navigation purpose, how the direction is take over from one point to another point. Either it's grabbing an object and taking from one place to another place. These global path plannings and local path can be constructed using SLAM, that is your simultaneous localization map techniques. So this is a basic architecture of your ROS navigation stack. See that some examples of embedded AI robotics projects. So given some videos placed in the presentations. The real helpful for that how that NVIDIA's are implemented in the robotics. So here first is a SLAM techniques. So visual SLAM techniques, how they is constructing that robotics uh, from the environment. So let us see that robotics bring that. First is taking the information of that input. So now you can see that our visualization, the left hand side, I mean right hand side, it construct a room environment using the LIDR camera sensor devices. And from that you can see that it's constructing 3D mapping. So this is the algorithms are implemented in the robotics using the Jetson Nano community. So let us see the next example. So same as well as here previously they used as a R visualization to construct the 3D robot. And in this image, in this video, you can see the Isaac site, Isaac simulator. Through this Isaac simulator, this 3D construction map can be constructed by the robotic of your Jetson Nano model. So you can see this the part of the room. Okay, next you see the next examples. Not only that construction of that mapping and also used in the autonomous vehicle. So let us see this here that deep learning technique can be implemented. So here we can use a mask or CNN or it may be a YOLA techniques. So that is a ResNet 50 technique can be implemented in this Jetson Nano. It can be detected car path plannings and what type of vehicle and what is the coordinates of vehicles and what type of vehicles are they. It also tracking the detecting the vehicles in the road land. And also right hand side see that the heat map of your that is the heat mapping of your robotics. So this is another example using that implemented in Jetson Nano. And also it is used in the UAV models. So in these UAV models, we can use that thermal, fire extensions in the forest area. So Jetson Nano is really helpful for to monitor that how much intensity of the fire will be there. So this is a real-time video can be given to the Jetson Nano, and it is trained that using the deep learning technique is a mask RCNN. So this is one example. And next we are going to see that the biomechanic robot and also gesture robot. So first is a biomechanic robot. Here the Jetson Xavier model can be implemented for the biomechanic robot. Here the disabled pants persons the bionic robot which is built for that. So the person has to doing the action same as doing the left hand side. So here the Jetson arrow is a very really helpful for
Sir, Manoj sir, sorry, you're muted, sir. Sir, Manoj sir, you're muted actually.
is it visible? No, I don't
Yeah,
know.
yeah. Okay now, sir. Okay now, sir.
Jetpacks.
Sir, Manoj sir, so sorry, but you're again muted.
I don't know when someone muting me. I think.
Yeah.
Okay. So here traffic density and counting using Yola V4 was implemented in the Amrita Chennai from students projects. So here we use a Jetson Nano developer kit and we implemented that finding out the traffic density and counting the vehicle. Here we directly given that image to that Jetson Nano and pre-trained the model using Jola V4 and it can be finally it is calculated that how many can be cars can be detected and bikes detected in this roadland. So let us see this video. So you can see this video. It can be the traffic signals. So we place the Jetson Nano. So these are the pre-trained. This is a video. So right now we are going to implement the real time also. We're going to place somewhere in the traffic signals, and we are going to counting the cars and bike using that Jetson models. So these are one another techniques. And next, not only that robotics part, and also we can find out the fish species identification in underwater robotics. Okay, so here we are doing the projects of fish species identification grading. So here first we can see the first five images. The top row is a sankara fish. It can be given a place in the different rotations and angles and translation and size also they differ. So first, you can see this, it is a top view, and second is a side view, and third is a corner view. And also we can be the multiple object of the fish species. And second, those are ore fish. We given around right now we given the two species. That is around 500 images we given that and trained the model. And finally is achieved at 95%. So it also very accurate and also very, very fast compared with that less embedded model like Arduino and Raspberry Pi. So it takes around 15 to 20 frames per second when compared with that Arduino, it's very less frame per second. So that's why this Jetson embedded family is very more reason advanced in the robotics. So these are that sorry, these are the AI embedded robotics projects nowadays we are doing, and also as well as taken from the Jetson community projects. And I have 10 minutes. Can I show some demo, ma'am? Is it possible? Or let me wind up. Hello, ma'am.
Correct, sir.
If it okay, if the time permits, I can show the demo. Otherwise, I can.
Yeah, no problem, sir. I think you can take another 15 minutes maybe.
Okay, just unshare my screen and sharing the whole screen.
Yeah, okay, sir.
Okay, let it be. Yes. Uh, yes, I'm sharing the whole screen. Is it my screen is visible?
It's loading, sir.
Just showing the demo of the Jetson and how it is working with the deep learning techniques. Yes. My screen is visible now?
Yes, sir. Yes, sir. It's okay now.
Okay, fine. Let us share my one more screen. So I'm going to connect. First of all, Jetson Nano has some get. I take that Jetpack software and I dump it to the board using the SPA card. Now the kernel will be activated and do the analysis action in the Jetson Nano. So before that, I'm going to only the connected to the Windows. So here there is a two mode. One is the head mode and the other is the endless mode. Head mode is we can directly connect it to the computer that is your. Sorry. Okay, fine. Is it? So the two mode. Headless mode is both the
Sir, your voice is not audible. Manoj, sir?
Is it audible, ma'am?
Yes, sir. Now, okay, sir.
Okay, fine. Because I connected my one more camera to show that that Jetson Nano. So here only I'm going to show that how the Jetson Nano is working and how that deep learning can be implemented in this Jetson Nano. So here we have two mode. One is a headless mode and a head mode. So I'm only take the headless mode. Headless mode can be connected to your Windows system, and we have some putty configuration. Through the putty, we can do the see the how the monitor of that Jetson pack module. Okay, so let us see that how it is working. That so this is my Jetson Nano. So let us see. I am going to show that Jetson Nano here. So this is my Jetson Nano. Is it visual, ma'am?
Yes, sir.
Connected. My camera is at the basic camera is nothing but just a model can be I mean camera signal interfaces through that this port. It is a this port, and also one more USB cable is connected with my computer to make the connection of your putty. That is your see that deep learning implementation of the deep learning, and one more is cable is connected with the LAN connections and power supply. So these are that configuration. I mean hardware part of this demo I'm placing here. Okay, now I'll show that how we can enter see that model right now. First we have to made a setup using headless mode. I already predefined the headset mode and make it as a login option, like same as how we open the computer and I mean switch on the computer. We it will ask the password, right? Same setup. We it will ask that. So I'm just giving my username. So just I'm giving that password. Then now it is entered that. So now we are going to uh, see that how using the we are opening the programming part, and we're going to run the program, and that AI model can be implemented in the Jetson Nano. The Jetson Nano grabbing the object and do the classification part. So this is we're going to see this demo. Let us see. I'm going to run this. I already make the file. So that is a Docker underscore run underscore. Yeah, 1 minute. Just opening my screen. So here, yes. So let us see, start our courses. So these are the course can be learned from the deep learning institution. So I'm just learning that, and I'm showing the demo. Let us see that my Jetson setups and everything can be implemented. 1 minute. Yes. So Docker, yeah, Docker, Docker, DLI underscore run dot sh. So I'm opening the run the SL which is file, and now it is open that. So when it is runs, it will activate one portal link, which is program already predefined the model. So let us start within a minute. Yes. So now my this HP, I mean HTTP is activated. That is a 192.68. So I'm just copying these values and I pasting here. Paste. Let us see. So I'm entering that and I'm giving the password DLI nano. Why it is not opening? Sorry. So it's opening the Jupyter lab book. Here we have some certain program. One is a classification and regression. Is it my screen is visible?
Yes, sir.
Yes. So first, previously I made a setup and collect the data, which is a thumbs up and thumbs down. I'm going to classify. If I show the thumbs up, the model can be understand and show that thumbs up or thumbs down. Okay. Previously I collect the data So these are the numerous data has been stored in this Jupyter notebook, and this is thumbs up, sorry, thumbs down, and these are the thumbs up. So these are the classification data sets are collected previously. So we can also collect. Let's see how it is working in this demo. And right now, first, before starting that demo, I want to check whether the camera is activated or not. So let us see, we have two type of program. One is a CSI camera and USB camera. I'm just opening the CSI camera to enable that. So here, we're going to run the model. So first, we'll check the one by one. So if it is working fine, then we will succeed it and we can see the demo. I'm running one by one. So now the root file has been enabled and the camera has been activated, and now the camera has been captured the object. And now let's see. Yeah. So now see that it also do the real time detection. So you can see that my Raspberry camera has been activated, and also it showing that demo. So this is that visualization from the camera using the Jetson Nano, and just keeps on running that because my camera is activated and successfully built in that the Jetson Nano. Okay, so once it is completed, if it is successful done, we can close this notebook and we can close this also terminal. So now I'm just restore the kernel or clear all the outputs because I'm going to run the classification part. Okay, I'm just closing that and I'm activate. Yeah, next I'm going to that. Before running the program, whether I have to check whether the kernel, different kernels are running or not. Let us see how it is running, whether check that. So right now, the camera is activated now, it is not shut down. So please shut down all. So shut downing that all and yes, close it. Now I'm going to run the program that is a classification of the detection. Okay, so now I'm going to run that. Run the program. Before running the program, my camera is selected or not. See here, there is a camera USB there. I am going to disable that. I'm just activating my Raspberry Pi camera V2. That is, this is my command line. That is a CSA camera. The Raspberry camera V2 model to be uncommented. Now we have to start the programming part, running that. So first is running that command, check the device number. Now it is verify that. Now the camera is activated. Yes, it is successfully built. And coming to this classification part. Okay, let us see what type of technique can be used here. Okay, so in this right now, I'm going to use only the ResNet 18 model. So here this very important point is whenever we are going to take the Jetson Nano family, we have to implement.
Sir, sorry, again, you're muted.
Okay, so I don't know who is meeting me. Okay, fine, no problem. Okay, so here that AlexNet and SkewsNet, ResNet 18, ResNet 34. Because these are the very lightweight component, lightweight deep learning technique. Only lightweight deep learning technique can be implemented in this Jetson Nano. If you go with a Jetson higher model like a AGX Xavier or AGX Orion, you can implement that high-end model like ResNet 153, Darknet 143, or Yola V7 or V6, V5. Everything can be implemented in the high-end model. But if you go with the Jetson Nano, you have to only go with the lower model. This is a very important thing. So right now I enable only the ResNet 18 architecture. And keep on running that. So now I'm going to activate and training part. So now we can see this interactions. In the training, we're going to see that approaches and last rate accuracy, everything can be trained in this Jetson Nano itself. We don't need any GPU computer. This Jetson Nano do this all process. Let us see that. So here you can see this, right? So my training model, and you can see this thumb line. So here see the data set A, categories, count, FOC. So right now I have data set A and B. It means thumbs up and thumbs up, thumbs down. Okay. So I have separate category that is thumbs up, thumbs down, and count around 48 or 50, whatever you can increase the data sets. and you just click the add, it can be added. And FOC. So here the FOC you can give minimum that 10 and maximum 100. Okay, because if you're using Jetson Nano, we have any high heat sinks should be there. But right now I don't have a heat sink. That is a cooling fan or aluminum coil material to reduce the heat. Right now only have some small heat sink. So in the Jetson Nano, so I'm just giving only the 10 FOG previously, and I trained the model. Now after that, it's going to save the model in this certain part. Okay, so I'm just loading the path because I already trained the model. I'm just loading the model, and it's just giving the only one for FOG. So because I don't need train the model, so it will take some time to start the model. So within a few seconds, it will do the FOG. After that, if you show our hand either thumbs up or thumbs down, it's going to show the prediction values. On it. So I don't know what one it. Camera is stable. It's training. Please wait. Yeah, now it is started for FOG. That is a iteration process. So once it is done, it's finding the previous data, collecting the data, and doing the classification part. Now the accuracy around what less should be the 0.8, and if it is a FOG, it shows comes around 19 or 88 percentage. Now I given only one FOG. If I increase my 10 FOG, it will be increase the accuracy and reduce the losses. Now I will show that thumbs up or thumbs down. It show the prediction value. Let us see. 1 minute. Okay, I have some low network connectivity that I cannot be share that. 1 minute, please. A minute. Give me a minute. Okay, any questions and anybody have any questions? So that's all about the demo. So if I'm sure that I can show that it takes some time due to the less network connectivity. Any question?
Okay, so participants, any questions from sir?
Yes, ma'am. Any queries? Sorry,
Sir, I have one question. I'm audible.
yes, ma'am. Yes, ma'am. Please.
Sir, so it was a wonderful session. Actually, it was so interesting. So the question is like, while you have shown some examples using UAV and forest fire detection, right, sir?
Yes, ma'am.
So for that case, whether ROS kind of operating system is useful or what? I just wanted to know. Like, there are certain humanoid kinds of robots where degrees of freedom are there. UAV is also there. For UAV purpose, is ROS necessary?
Yes, it is necessary, ma'am. Whenever we are going to do doing any unmanned vehicles, RS is compulsory.
Okay. Okay.
So because
So in that, what
because
might be
we are
the
going to
publisher like?
sorry, ma'am. Sorry.
In that case, what are all the different publisher components, sir?
Depends upon the application, ma'am. Whether it can
Okay.
if you want that move certain action. For example, I want to capture the images, so it will be publishing activities. I want to see the what is the thermal activities. It is one of the published activities. Depends upon the application. It can be defined yours. So here, for example, you're doing the UAV, finding the thermal activities in the forest area. So you have some control in the ground state, right? So from the ground state, you can see the information. The data can be processed from. Sorry, I can't
Sir,
able
yes, sir,
to
you're
hear.
audible now.
Yes, okay, fine. I think all are muted. I think so, ma'am. Any problem in that?
No, no, like I was trying to do that. Sorry, sir. Like because people were trying to repeatedly do something, so I did that.
Okay, okay. Okay. I'm just explaining that
Yeah, yeah,
some.
sure, sure. Please, sir.
So here that in UAV we have certain action. Okay. So for example, that data can be capturing in Jetson Nano, and if you have different publication, for example, if you want only that finding the thermal activity, the data can be passed from main UAV to the control unit, and we have different publication. Or we can create that before we sending the UAV. So it's all about how we are going to make the setup file. I hope that I answered that, Dr. Sridevi, ma'am.
Sir, yes, sir. So participants, since I've muted everyone, so if you have any queries, please raise your hand so that I can unmute and you can ask the queries. Okay, so fine. I take this as no more queries. So Manoj sir, thank you so much for the excellent session, sir. And that demo was really so extraordinary, and it's really inspiring that you did very good projects and you motivated so many students to do so many very good projects and all. So thank you on behalf of VIT University for taking up this session, sir.
Thank you, ma'am. Thank you. And I'm posting my